Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 73 minimum number of moves to make Palindrome. So this one was a very hard problem for me. I don't quite know how to explain it, to be frank. So hit the like button, hit the subscribe button, join me on Discord. That's a terrible segue, but nonetheless, it's true. So the part that there are a couple of observations that I would make, which will explain this problem a little bit better, but I probably am not going to be that exhaustive about it. So the first thing first is that this is a greedy solution, and with those you have to really prove to confirm that they're correct, but it's also obviously harder, easier said than done, and super hard for me in general. I think the one thing that I would say is that, given a string, let's start with this one, right? So the way that I would think about it is that, let's say I have this string, and let's say maybe like we have something like this, right? The idea is that, so the greedy thing that I would say is because let's say L is on the outer side, right? If it's not, let's say you maybe want to do Y. Well, if you want to do Y, that means that you would have to move Y to the left anyway, and in that case, it is exactly the same as moving L to the right, right? So in that way, I definitely don't think I explained this well, to be frank, but in that way, greedy works in that you always start from one end, and it doesn't matter which end, because of that property, right? For example, this T, if you want to move this T to the left, which you have to match it, it is equivalent, because after you remove it, then you get this, right? And by removing it, I mean like just moving it to the outside. And because one of the properties about the swap is that if you don't move, it's either we do this L now or you save it for later, right? If you save it for later, this is equivalent to this moving something to the left or moving this to the right. So in that way, yeah, maybe I'll do another example. Another example could be like LT. Maybe that's even the first one. Nope. In this case, you have two choices, right? You could move this L to the right or this T to the left, and you could argue that they're equivalent because of in either case you're swapping the order that you're doing it, and by doing something in the so you have to do it one character on the outside. So I think once you kind of convince yourself of that, and I'm not gonna lie, my explanation is kind of lacking, because this is a greedy proof, and I think the observation is true. I probably don't know how to quite explain that part, but yeah. But once you accept that, I suppose it's just about making sure that you have the odd number as well, or odd number thing. For example, you have AA BBC or something like that. You want to make sure that the C is in the middle, and that's basically the idea that I have. So this is the idea, right? Greedy and keeping track of the middle one. So yeah, and this is gonna be, I think, n squared, to be honest. Wait, is that true? No, yeah, I guess this is gonna be n squared. But n squared is going to be fast enough. But basically, for every left, we try to find the rightmost character to swap all the way to the right. So then basically, because I think maybe another way to explain it is that, let's say you have, I'm doing X as not the character X, but just like, okay, maybe empty spaces, right? So then, let's say you have L here, or let's just do A, and then you have another A here, right? So the thing is that to match these two A, you have to move this A to the outside, right? To something like this. But that's exactly the same as, that's exactly the same as moving this character X to the right, or all these characters to the right. So I think in that case, that's why they're equivalent, and that's why greedy works. So basically, that's all that is. I do a search, and you can actually implement this in a better way, I think, if you really wanted to do a lot more bookkeeping. But I actually even physically do the swap because I knew that it'll be fast enough. But yeah, but basically for every left, you get the rightmost right character. So we just keep on searching for it. If the left and the current meaning that if left, you cannot find another character for left, that means that that is the unique character. So then we set that to the middle, and then we just move it to the left, and then we continue. At the end, we just do some math to make it move it to the middle, and that's it. This is going to be n squared because, of course, this search is going to be linear, and this is linear, so that's that's quadratic or n squared. In terms of space, this is O of n, because we just the way that I did anyway, I just have a list. Maybe you could do a little bit better, but meh. Cool. Let me know what you think. I think this is a little bit, I think like once you get the idea, this is way, obviously the implementation is relatively easy, but the hard part is about not even getting it right per se, but proving yourself correct to do it. And once you do that, then it's okay. It's very hard on an interview, I'm not gonna lie, so I don't know how I feel about this one, because it almost rewards people who YOLO a little bit and maybe don't prove. I spent a little bit of time thinking about this, and I honestly, like if you ask me, it's more like an intuition gut shot, and also that I'm willing to take a wrong answer, but I really don't think I have confidence on this one when I submitted it. So yeah, proof by AC is not a great proof, right? But anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live in the contest next. Submit. Okay, that was a very sloppy one. That's yikes. Okay, let's see. Minimum number of moves to make palindrome. You can as one move you can make as a palindrome. I feel like I know this one, but there's definitely, was it a swap? This feels familiar, but let's see. Can I do dynamic programming? Right. Is that the one? Where you have B, you go okay. Each one, and then you add another one from this adjacent, and then don't know if I know how to do this one, to be honest. So apparently 1,000 people have gotten it, so how did I even do it? This is such a yikes, because wow, people already finished, but this one was, Q3 was a mess. Should have gotten that one without the 2 penalties, but I was just doing it another way for some reason. Okay. It feels dynamic programming-y, but I'm not quite sure. I do remember a problem similar, or I don't know if it's this one or something similar, where you start with one character, DP to do. What is the DP recurrence here? All right, let's say we have A. Okay, so that's already n squared state. That's gonna be n cubed, so that's gonna be too slow. Okay, so okay, so here it's not clear to me that you always want to chop it off anyway. Wow, how long did it take? People got it. Wow, 5 minutes. Huh. Oh, wow, 3 minutes. Good job, douche. Huh. Let's see. Can I do greedy in some way? I think I was thinking of minimum insertions to make a thing, but let's see. Is there a greedy way to do it? What would be the idea behind a greedy if there was a greedy? Is it a longest common? No, I was thinking of maybe there's a way to do like a longest common subsequence type thing, but I think that's for insertions and not for swaps. I think it's greedy because of an invariant that you have to come up with, which is that if we look at the left and right borders, let's see, you're basically forced to you're forced to, because if that's not the number that if that's not the character that you're doing, you would have to swap it the other way anyway. So okay, I think now that I'm convinced, maybe it would be something like that. Okay, let's see if that works. I don't know. Left is equal to 0, right is equal to -1. Okay, so it's just greedy, right? Then yeah, okay, because if not, then you have to move it left anyway. So okay, maybe that's fine, maybe that's true, I don't know. Oops, why did I do that? Yeah, okay. And then now we just have this is right? I always forget how to do that converts to a character way. Okay, fine. Okay, so then now let's say while left is less than right. You could also do a binary index tree, I guess, but that doesn't even make sense. That's unnecessary. Okay, so current is equal to right. I guess what happens if it's equal to itself? I have to think about that one. Well, if it's equal to itself, that means that that has to be in the middle. Do people get wrong answers for this one? Okay, so then now, oops, I want this to be current. What happens if it gets to itself, right? So this has to have this. Okay. Okay, so let's say if left is equal to current, I have to figure out how I want to do this. And we want to move left to well, then we want to move it to the middle by incrementing. Okay, this is so yikes. Let's figure out later. Let's focus on this part first. So okay, so so now for x in range from current to right, swap I guess in this case we just So this is a very awkward way of writing it, but that's fine. Maybe. I don't technically need to do this. There's another way of writing it, but I want to verify to myself a little bit, that's why. Okay, this is just not right, but so current, well, this is -1 anyway. Okay, that's not quite right. Alright, let's oh, I forgot to increment left, that's why. Okay, maybe this hopefully does a little bit better. Okay, still no. Okay, so then now let's see. Okay, A, B, B, A, and then it moves to A here, but actually it wants to, the A should go all the way there, so maybe this is right. Okay, this is good. Well, we have the right answers now, but like I said, alright, let's try this, but with a C in the end. Okay, so this is clearly not right. At least that's the answer, though it might be good with respect to the answer. I mean, I don't know if this answer is right, but this is definitely not right. So, okay. If left is equal to current, I mean, we're guaranteed that. So how do we want to move this to the middle? Okay, so okay, we do this if this is the case. Else what happens? What does this do? Else so okay, let's actually print out this array so I can kind of see what it looks like after every iteration. Not clear on this one. Okay, so after one iteration you moved A, B, you moved to B, and then C. That actually may be right, but that's just coincidental. So let's do C, A, A, B, B. I think this one will give me the wrong answer. Yeah, so then now C doesn't see anything. Get it? Okay. And then now it's very awkward because the A, because the C, okay. So how do I want to do this? This is the case. Continue, maybe something like that. So then we can at least get the things correct, okay? And then now, no, that's not good enough. Let's see, okay. Middle is equal to left, maybe, something like that. Also keep printing this, but yeah, okay. If middle is not none, then we keep on, okay. Go, okay, G is equal to n over 2. Okay, we assert that n minus 2 is equal to 1. So then this is the index that we want to go to. So then we can do swaps equal to absolute value of middle. So something like that. Is that right? I don't know. I mean, I think this is right for this sample, but I don't know if this is right in general. So we want to do another like AC, A, B, B maybe. And the answer is by moving C. This should be 1, right? Because if we just move C to the thing, oh no, okay, I think this is right actually. Because yeah, okay, this is very awkward though, so I don't know. I'm going to YOLO a little bit, to be honest. I think that's okay. Let's just YOLO a little bit. Oh, cool. Yes. I actually was a little bit YOLO on this one. This is a greedy problem, and that's the problem with greedy problem. That's a problem. Yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem. I'll see you later. Stay good, stay healthy, to good mental health. Bye bye.